Thank you all for being here at ThreatCon. My name is Jim Manico, and I want to talk to you about a really important aspect of application security. This is about process. This is about the software development lifecycle. All right. That's right. Back to your seats. We got to talk on. Let's get back to your seats. All right. My name is Jim Manico. I'll be your presenter today. I'm really happy to be here. This is my second ThreatCon, so again, really happy to be here in Nepal. We're going to talk about the building blocks of the software development lifecycle. That's what SDLC means. SDLC means process. How are we as a group of people going to organize to build secure software? We'll take a look at security requirements and the whole idea of we need to plan for security. Security doesn't just happen. It never just happens when you're building software. You have to intentionally decide that you want to build secure software and have a process around that idea to have any chance of writing secure software. We'll look at threat modeling as one of the activities and different kinds of secure coding techniques, as well as some monitoring after the fact. So let's go to the beginning. Let's look at the building blocks of what a secure lifecycle looks like. No matter what kind of software process you have, there's going to be some kind of early analysis phase, business analysis. There'll be some kind of design phase where you're doing technical design, prepping your plan. Some kind of implementation phase where you're coding and building software. Some kind of testing phase, and some kind of operational monitoring phase. It doesn't matter how you're building software, you're going to run across these 5 phases, and each one of these phases of building software requires security in some way. And so this is an old joke about project management and software security. This picture here is how the customer described the problem. This is how the project leader understood it. This is how the analyst designed it. This is how the programmer wrote it. This is how the business consultant described it. This is how the project was documented. A little bit too true in the world of Agile. This is what operations installed, and this is how the customer was built. The whole point is that, and this is how it was supported. And this is what the customer actually needed. The whole point is that poor communication always leads to epic failure in software development. So what is a secure software development lifecycle? It's communication between all of the players involved in writing that software. Your testing team, your automation team, your developers, your management, all need to be on the same page defining what secure software is to have any chance of building secure software. And here in Nepal, there's some amazing developers who write software for your banking system, for infrastructure, for power. There is a lot of software being built here in Nepal, and it requires precision and discipline to achieve security. So, a good step, number 1, is to publish a document describing your software development lifecycle. And this seems petty to a lot of people, but this is like my indicator when analyzing a team. This is my indicator if this group cares about building secure software. If I see some kind of document, whether it's up to date or not, it's usually a sign that they're moving in the right direction in terms of process to write secure software. So, but let's be realistic though. This is a list of ideas from the Automotive Linux group. This is a group that builds software specifically for automobiles. And one of the characteristics of this world is, unlike Tesla, in most of the world of automotives, when you push software to that car, it is painfully difficult to update that software. To this day, picture time, excuse me. Okay, to this day, you usually have to bring a car to a dealer to get software updated. So, and you're talking about people's lives. You're talking about the safety of people when you talk about automotive software. So they really need to get secure software right the first time as best as possible. And here are some of the principles from this very precise group in terms of writing software. Security is invasive. It cannot be applied as a patch at the end of the project. And you must be developing with security turned on. So if you're using a dev server or some kind of local build environment, you want all of your security turned on. HTTPS, your authentication system, all the different pieces of security we want that turned on in our development process as early as possible. Back when I was writing software, we would do things like have a dev server where we didn't have HTTPS turned on, and we would just code to HTTP and get it working, and when we would push this stuff live, things would break because we weren't developing with security turned on. And this is a really important concept. Also, don't underestimate the resistance of your developer team. A developer team by itself will almost never write secure software. We need to put roadblocks and checks and all kinds of automation in place to achieve security. Developers for 50 years have been trained to get the job done. They get awarded for completing functionality, for pushing code live. Mario, how often do developers get awarded for writing secure software? Never! And who gets all the glory in the industry of security? The hackers, the bug finders. And like Mario was saying in his keynote, we need to change that model so developers who are fixing bugs, developers who are writing secure software, developers who care about strict process and security, they should be rewarded. Now, pen testers, I know you're a pen tester, Mario. Pen testers are important. We need to find bugs, but we need to glorify the fixers way more than we do now. And that was a point you were making in your keynote, and I agree. And another important point is if your team writing software does not have an application security expert embedded with the team from day one, your chance of doing secure software is near zero. And this is a difficult problem because even to this day, to get authentication right, to get user interface security right, to get access control right, and all the other esoteric bugs that show up in secure software, it is an expertise that is unique, that is difficult to achieve, and necessary to build secure software. And that expert may be a member of your team, it may be a consultant, it may be an online service that you're using to get advice from another consultant, but embracing the need to have an expert on your team is critical and fundamental to writing secure software. A team of developers who write software without that expertise will always build insecure software, in my experience. And so what we're looking at is to embed software, to embed security in the requirement phase, in the technical building phase, while you're coding, while you're testing, and during deployment and operations. Every phase needs to account for security in some way. This is my vision of what your SDLC should be. And this is not really standard. The point I want to address is before developers start coding, what should be in place? This is the question I'm trying to address. Most teams I work with, they have an idea and just start writing code and decide to add security on later in some way. And this is a big fail. So I think that writing software, it's expensive, it's time consuming, requires a lot of precision to get right. And what this tells us is that we need to have developers prepared to write secure software before they start. So look at this, the code and test prep phase. You should have an automation system in place that checks for security as you're coding. You should be using specific frameworks and specific libraries that achieve security that your team understands how to use and secure. Your developers and your QA team should all be trained in security in some way, and we should be ready with a test plan around how we're going to test for security along the avenue of writing software. And almost nobody does this. More so these days, but very often teams just start writing code, they'll deal with security later. And this is always a failure, and a very expensive failure in my experience. More pictures, excuse me. Thank you, all right. So what is DevOps? One of the main changes that we see to software development in the last 2 or 3 years is the movement towards DevOps. And what is DevOps? Now, a lot of people have different definitions. Here's my real definition of it. It's automation. It's really about making sure that every phase of the life cycle has some kind of repeatable testing in place to enable developers to work fast, but still achieve a rich suite of automation in terms of security testing that we'll look at later in this presentation. And this is not a standard definition. We can go read Gene Kim's book on DevOps and the whole movement around this. But I think it all comes down to when you're writing code, every time you build, every time you check code into your code repository, a large suite of tests should be run every single time. And as you mature this capability, the benefits are dramatic. When I look at teams who do automated security testing versus the teams that do not, those that do move faster in a much more secure way. That doesn't stop the need for pen testers. But if we have good automated testing, then we can direct our pen testers to look at the difficult things. Why would you want to waste a skilled pen tester's time at looking for petty BS like XSS? That's a waste of your talent. No tester should look for that garbage anymore. We should use automation to do it, move on, and look at the difficult things like our crypto layers, our authentication layers, our password storage, our integration with identity providers. That's the stuff we need to look at. Look at, how about new standards like OAuth and OpenID Connect? These are insanely complicated. It takes a lot of time to analyze them carefully. That's what our penetration tester should be looking for, not XSS. That's too easy. That's shooting fish in the barrel these days. Just my take on this. Let's move on here. Now, what DevOps is about, it's about automating the building of software, automating the testing of software, the deployment and the monitoring of software. And this is not something you can buy. You can't just buy a DevOps and start using it. You usually want to build this yourself through open source. The most common DevOps infrastructure software is a product called Jenkins, which is open source. And now how you build and how you compile, all these steps of the construction and deployment of software becomes automated. And you don't get this for free. You have to code and build, you have to tune and build this yourself, specific to each team. Let's talk more about what that means. And so when we look at continuous delivery and continuous integration, these are the most important parts of DevOps. A lot of people challenge this definition, but I ask you, if you're doing DevOps without automation, then what are you doing? You're not really doing DevOps, in my opinion. So continuous delivery gives you deployment automation, trunk-based development, test automation, and then the whole benefit of DevOps is we begin to address security earlier in the life cycle. The moment your first developer writes the first line of code, that line of code should go through hundreds of security tests. And that should happen every time you're writing and checking in code. So it's a natural part of how you write software. This is why we have to prepare our teams before we start writing software. We want to have Jenkins and all these security testing tools configured and in place on day one, all the way through the project. And again, it's rare where teams want to do this. And so we'll come back to these principles of how to wire in testing tools in just a few moments. Well, let's take a step back. One of the things that I like to ask is, what does secure software mean to you? Anybody in the room, can you define for me what secure software is? What do you think, Mario? You want to play? It is. But how do we approach secure software as a team without a clear, common understanding of what we're approaching? My answer to this question is establishing clear security requirements. I believe that we can reduce security to a list of technical requirements that we inform to the developers. Who likes to do requirements and like project documentation in the current era? That would be nobody. But when it comes to security, our entire world of development, the entire world of software developers, we are all new at this. So my belief is when you are all beginning to build software, you're building banking software, infrastructure software, power generation, power grid software, that we should understand what security should look like before we begin those projects. One of the standards that I work on to achieve that helps build this requirement list is from the Ojas Foundation. This is the Open Web Application Security Project. It's the Application Security Verification Standard, version 4.0. This is approximately 280 requirements in 3 different levels of severity to help inform the developer of what secure software is. So that question I just asked you, what is secure software? My answer is, for web and APIs, it's approximately 280 specific technical requirements that you need to address in some way during software development. Now, and again, very few people like to do this, but it's important that all of us writing software together are on the same page around what secure software really means. Here's a little excerpt from this standard. Here we are defining that verify the definition and security analysis of an application's high-level architecture and connected remote services. This is level 2. Not every, this is like any software that has sensitive data should account for this requirement. Or down here, verify the use of unique or special low-privilege operating system accounts for all application components, services, and servers. When you're running a web server, the operating system account running that web server should have the least privilege in play, should have as least access necessary to run that particular active web server. And I'm just mentioning a few here. And this standard is not meant for you to follow perfectly. The way you use a standard like ASVS is to take what we have and fork it specific for your team. Start with level 1. Get that, that's about 100 requirements. Get that done well in your team. When you've achieved level 1, work your way up. Or maybe you don't like our levels. Maybe you want to fork the standard for your team and build and use those requirements to build your own standard. I'm less concerned about you following this exact standard. I'm more concerned that you have an idea of where you're going before you start writing code. And having a list of security requirements, I can't say enough how fundamental this is in helping educate and drive your software teams in the right direction. And so let's jump ahead here a little bit. The other big question is, well, I have a lot of existing software right now. Who works at a company with a lot of legacy software? Anybody? And how much of that legacy software has good security? Probably a big 0, right? So we have to approach this problem. I think it's getting easier to write secure software, but the bigger problem is all the legacy software we have out there today. So I recommend 2 approaches. And so when you're first looking at old software, I recommend the concept of a security sprint. This is the idea that we're going to look at one problem, one micro problem, like XSS or SQL injection, and have everybody on the team, every single developer on that team, spend a couple hours or a day or a couple days fixing just that one problem. This should accomplish 2 goals. Goal number 1, you fix those bugs. And by the way, if you're not committed to fixing bugs in software, you're not doing security. Let me try this again. If your teams are not committed passionately, and you've also educated your team on how to fix those bugs. So this problem shouldn't show up again, ideally. And this is the power of a security sprint. The other thing is, once you've gone through your security sprints for dedicated issues, we shouldn't have to go back to those sprints. Those issues should be fixed and dealt with every sprint from that point on. I've done this with several different teams recently, and we've taken large teams who had no idea what things like SQL injection were to having all SQL injection eliminated in their company within a matter of a couple weeks. So this is a very powerful process to consider when dealing with older software. All right, where else are we going here? Let's talk about the actual coding phase. So once we have our automation in place and we're ready to start coding, what does it take to really write secure software? Well, again, like I mentioned earlier, we need secure coding libraries and different security services and frameworks. Like these days, if you're building a user interface, you probably shouldn't do it from scratch. You should probably use something like React or Angular or Vue, where many of the problems of user interface security are addressed. If we're going to build authentication, we should not build this ourselves. We should use a formal identity provider or identity provider service. Once we have all those pieces in place, now we can educate our team how to use those components in a secure fashion. We want to make sure our developers are aware of these security issues. This is a little self-serving, but your teams need to be educated on how to write secure code. Even just the basics will go a long way in helping your team construct secure software. Like I mentioned earlier, we want to have secure coding standards and requirements, so we're all moving in the same direction as to what secure software should look like. And we want to have security audits and code reviews, penetration testing and automated testing as much as we can. When we have all these pieces in place, we can move fast. We can innovate fast. We can build functionality fast and have an infrastructure of security around the software that we're developing. But it takes a little planning, some automation construction, and a commitment to working on your security environment before you start writing code. And so secure coding libraries are really, I'm going to jump ahead here a little bit here. And by the way, every single study I've ever looked at, they say that the cost to fix security bugs is radically more expensive late in the life cycle, right? So here's the cost of security, here's the cost of software bugs, a real famous study from IBM from a couple years ago. They're showing that it's about, if you fix a bug early in the SDLC, during the design or early phases, the cost to fix a bug is like 25 American dollars, right? Yet, if you're trying to fix a bug in production late in the life cycle, that becomes a $15,000, $16,000 problem. So not only is it wise to address security early in the life cycle, it saves you money. If you believe you're eventually going to be forced to fix these bugs, then the cost to do so early is almost nothing. And the cost to fix bugs in production is extraordinarily painful. Every single study I've ever looked at says the same thing, that the cost to build the cost to fix bugs in production is hundreds of times more than addressing it early in the life cycle. So again, planning, automation, preparation before we write software is critical for modern security. So there are three kinds of tools I want to address before we finish this presentation that we need to have as part of our automated security testing. The first one is static analysis. Does anybody here use static analysis in their work at all? This is called SAST in our industry, or Static Application Security Testing. This is all about using a tool to look at your code for vulnerabilities. There's a whole industry around these tools. In the world of Ruby on Rails, we have Brakeman. In the world of Java, there's many different tools like Fortify and Checkmarks that address these problems. These tools are expensive, but these tools are necessary to make sure that every time a developer checks a piece of code into GitHub or checks a piece of code into your code repository, that a suite of security tests is done automatically before that check-in is accepted. And so this is basically, it's called static analysis because you're looking at the code now, not the running application, but the actual code base itself. This is testing, this is a security automated testing tool class 1. My belief is if you're working at a bank, if you're working for the government, if you're working for infrastructure, and you're not using a static analysis tool to check for security bugs every day, I consider it to be negligence from a security point of view. This is nothing special. This is something everybody writing software should be using. The second kind of tool we should be considering is dynamic application security testing, a DAS tool. Anybody here use Burp in their work? Burp? You use the scanner inside of Burp? That is a DAS tool. And by the way, Burp is very inexpensive. And the scanner inside of Burp does better than some tools that are hundreds of thousands of dollars. So Burp and Burp Pro is a very powerful DAS tool. What Burp does is it scans the application, simulating the activity of a penetration tester looking for bugs. This is a little bit more difficult to deploy as a tool, and it's only useful later in the life cycle when you can actually build a running version of the application. This is why I think we should start with the static analysis tool. With the static analysis tool, we're looking at the code. We can use those tools immediately, day one, when you first start writing software. And then down the road, when you have a running version of your application, we can start using a DAS tool. And so the combination of these two tools are extremely powerful. Static analysis code scanning tools, they look for theoretical bugs. Dynamic scanning tools look for real world bugs. And together, it gives you a really strong idea of what bugs are going to be in your software. And it's relatively easy to deploy these in the modern era. The third kind of tool is looking for third-party libraries that are insecure. So again, I believe we all want 3 basic classes of tools running every single day as we're building code. Static analysis, looking for code level problems. Dynamic analysis, scanning your app, simulating the activity of a penetration tester. And the third class of tools, relatively new, is third-party library scanners. In my opinion, the problem of third-party libraries is the most severe problem when it comes to building secure software. Who here writes software or works with software developers as part of their job? Who here's coding? How many third-party libraries are you using in development? Anybody know? What do you think? What's that? Loud. So many. Yes. How many? Hundreds sometimes. And how many of those libraries are perfectly secure? Almost none of them. Even some of the most important security libraries that we depend on, they themselves have vulnerabilities and problems. So one of the things I recommend is that you use one of these third-party library scanning tools. From the Ojas Foundation, one of our flagship products is called the Ojas Dependency Check product. This is extremely powerful. It's something you can, for free, wire into your software development process. So every single time a developer tries to check in a piece of code, this tool will test if any of the third-party libraries have a known security bug to force you to update that library. There's also a tool called retire.js, which looks at the JavaScript that you're using on your website to make sure it's not out of date with the known security bug. I run retire.js as a plugin in my browser, and I watch like some of the biggest banks, some of the biggest money transfer services, government websites, medical websites, all on their homepage with dozens of insecure libraries driving their website. And this problem needs to stop. So the whole point is, when I started working on software, the idea was, let's use a piece of third-party code. Let's use a third-party open source library. Let's put it into our application. And if it's working, don't fix anything. Leave it alone. Never update it if it's working. And this idea is terrible today when it comes to security. Today, when you're using third-party libraries, you want to check every single day if any of those libraries are out of date, and if they are, update them right away. And this is something that nobody wants to do. Nobody cares about this. This is why we have so many security problems in the world today. One last thing I want to talk about is we need some kind of center of excellence. Most developers I meet, they want to write secure software, but they need help. They need to ask questions. They need to have a portal to go to understand best practices for your company. So this is one of the most important people issues, is that you need to have an expert as part of your team, as part of your company, to help drive these standards when it comes to writing secure software. So what's the lesson here? Number one, have an expert in place. Number two, have automation, static analysis, dynamic analysis, and third-party library scanners as the basics that you need in your software development team to write secure software. Without these four things, the chance of you writing secure software quickly goes to zero. Why are you laughing? Any comments over there? No, it's okay. It's okay. No, he's like, no, go away, Jim. Okay, it's fine. I'm going to do a shortened talk to make sure we have our break. Our next talk will be at noon. Before I finish up, though, does anybody have any questions about anything we just talked about? Well, I thank you all for being here at ThreatCon. If you have any questions for me about building secure software, I'm jim@manico.com. Please enjoy your break. We'll be back at noon for our next talk in 15 minutes. Thank you very much for your time, everybody.